Hi, I'm Chris Otero. In this video, we are going to dig in the anatomy of an MtF cube. The MtF cube. If you worked with Algo 1, you came across it. But what is really an MtF cube? The MtF cube is a result of the simulation. Simulation engine, like Scratch, will store in the MtF cube the result of the simulation for selected simulatable attributes. So what is a simulatable attribute? A simulatable attribute is an attribute for which the value will change depending on the time step and or the scenario. Things like theoretical value, for example, are simulatable attributes. The selected simulatable attributes are stored in the cube during simulation for every single instrument, scenarios, and time steps. This gives us the three main dimensions of a cube: the instrument dimension, the scenarios dimension, and the time steps dimension. The size of those dimensions will vary greatly depending on your need. Instrument can go from a few dozen to a few million. Scenarios usually start at around 500 and can go in millions as well. Time steps are usually less than 50, and the simulatable attributes as well are usually less than 50. But when you multiply the number of instruments by the number of scenarios, and then the number of time steps, and then the number of simulatable attributes, you will end up often with a huge amount of data to store in the cube. This is why often cubes are split between different files on the file system. So now let's talk about what's not in the cube. What's not in the cube are attributes that don't need to go through simulation. Attributes that will not vary depending on the scenario or the time step. Things like notional, things like instrument name, expiry date. Those sort of things are not found in the cube. That is why we often generate an instrument file that contains those attributes alongside with a cube, so that your reporting tool can have the attributes that describe the instrument and the simulatable attributes as well. The cube do not contain any aggregated number either. For example, in the cube, you will find the TO value, but you will not find any var. This is because the var will get calculated by your aggregation engine on the fly during reporting. The aggregation engine will look into the cube, will get all the TO values for one time step, for example, and will be able to then compute the var. This means that you can choose at the reporting stage whichever confidence interval you want for your var. Let's have a look at cube files. Cube is made of two main files: a .dat, that is a binary file that contains the raw result for the simulation, and a .csr, a cube manifest describing the data contained in the .dat. So this is the content of a .scr, a cube manifest file. As you can see, it's an XML file. It contains lots of information. The first thing we should look at is this line that is highlighted here, the storage ID. This gives the location of the binary file associated to this file. This means that if you want to move the cube files from one directory to another, you will need to update the SCR file and put in it the new location of the binary file. Then we have information about the scenarios. If I expand it, I can see that I have all the information about my scenarios. At the top, I have the name of my scenario set, MC consolidation. Then I have the name for each scenarios and its weight. The weight of the scenario is the probability for this scenario to occur. This means that the sum of all the scenario weight in a scenario set should be equal to 1. Then we have another section here, which is time list. The time list section contains a list of all the time steps defined in your cube. In this example, you only have one, but you can have as many as you need. The next section lists all the attributes that are stored in the cube. Once again, in this example, we only have one, but you can have as many as you need. Then we have the simulatable dimension information. In this section, we will have the description of all the data that is stored in the cube. For example, here I can see that on offset 0 and on 8 byte, I have information on my portfolio. The ID is dummy portfolio consolidation, and the information I have is position unit. Next, I have on offset 8 and still on 8 byte for a portfolio, this time it's a consolidation portfolio, I have my attribute position unit, and so on and so forth for all my instruments. This concludes our video on the MtF Cube Anatomy. Thanks for watching.